Isaac Newton isn't the first person that ever saw a spectrum, right? He's the first person that tried to lay it out scientifically. And where spectrums and prisms really originally come from are as ways to provide light into dark spaces. So deck prisms on ships were the first types of prisms. They could take light that was coming down onto the deck of the ship and then project it down into the hull of the ship. So if we take one of those out and shoot white light through it, we can get it to refract the light and spread out the different wavelengths of light and then see the naturally occurring spectrum. Can you think of a naturally occurring spectrum? Hopefully you would answer a rainbow. And so from that, the idea is that we can then fold this spectrum into a circle, because on one far limit is red or infrared, and on the other far limit is ultraviolet, which is violet red. We could then fold this into a circle and then understand color as a wheel. And so this is the artist color wheel, and it's all based off of what Newton figured out. We need to isolate out some color terms. The first one being hue, and that refers to a particular color. So red would be a hue. There are millions of hues that the eye can recognize. We've got 6.5 million cones in our eyes, and you can remember cones are associated with color because they're a C. So they take in and sort out various stimuli of color, and those are then sent to the brain. But not only do we have color sensitivity, we've got darkness and brightness sensitivity, and that's done by the rods, and there are 100 million rods in the eye. So we've got more variance in brightness affecting color than just hue itself affecting the color perception. So here's some key terms. Value, and that's the brightness that I was talking about, regardless of the color. So white is the lightest value, black is the darkest value. Halfway through that is what we call middle gray. And you guys might know this. Object or local color is what appears to our eyes and is determined by what wavelengths of light are being reflected. So a red cushion appears red because all the white light is hitting it, and everything except for red is being sucked out or absorbed. And so our eyes see the red that's been reflected back to our eyes. When everything is absorbed, we see black. When nothing is absorbed, we see white. And technically, black and white are called achromatic. So they're not true colors. They're not hues. They're achromatic or without color. Studio. I'm in the studio now. Here are some super key terms I want you guys to use correctly now, forever, the rest of your lives. Tint. A tint is when you add white to a hue. So if we've got red and we add white to it and we get pink, pink is actually a tint of red. Shade. A shade is when you add black to a color. And finally, a tone is when gray is added. So tint is when white is added, tone is when gray is added, shade is when black is added. These are messed up terms that people misuse all the time. So you should know now that you're trained what a tint, a shade, and a tone are. So when you're talking about one orange versus another orange, you won't say a different shade of orange unless you're talking about the original orange with black added to it. So there's two different types of color, the way the color is produced. There's subtractive, and that's like what's happening with paint or fabric. And the primaries there are red, yellow, and blue. And there's also additive, which is projected light. And the primaries there are red, blue, and green. So additive mixtures are light mixtures of color, so naturally or artificially produced. When added together, they make white. So you can remember additive adds up to white. So for example, natural and artificial light sources, monitors, screens, theatrical lights, iPhones, whatever, anytime that a light bulb or the sun is projecting straight into your eyeball, that is additive light. Subtractive, on the other hand, is just like the example of that red cushion that we saw earlier. Pigment mixtures that absorb light and bounce other wavelengths back at you. If you absorb all the light, again, you get black. So examples being surface coloration, paints, dyes, natural pigment. So additive color is projected and adds up to white. Subtractive color reflects light and makes black. In terms of color perception, though, it doesn't really matter how the color is produced. Like if red is being shined directly into my eye, it's not like I'm going to interpret that necessarily different than if I see red paint. And so we'll be working mostly with subtractive mixing, or working with paint. A color scheme is just how we put colors together. And color schemes are generally meant to feel harmonious. They look like they do not lack, they feel complete. Except for a dissonant scheme or clash, they're meant to feel unsettled and thus not harmonious. Later in the class, we'll be figuring out how to determine what will look good together.